Have you ever wondered how a whole network of computers, the ones running your favorite online service, all agree on the same information at the exact same time? And how do they pull it off without having one single master computer that could fail? Well, the answer is an amazing process like the Raft consensus algorithm. Today, we're going to unpack this invisible election that really makes the modern internet possible. All right, so here's our game plan. First, we'll lay out the big problem we're trying to solve. Then, we'll get to know the players and the rules of the game. After that, we'll dive right into the main event, the leadership election. We'll see what the leader actually does. And finally, we'll tie it all together and see why Raft is such a huge deal. You know, at its heart, Raft is all about solving one massive challenge. How do you get a bunch of different machines to act like a single unified brain? When you don't have a central boss, you absolutely need a bulletproof way for them to agree on one version of the truth, especially when things go wrong, like messages getting lost or servers crashing. Now, there's a technical name for this. It's called total order broadcast. And the key word there is order. See, it's not enough for every computer to get message A and message B. They all have to agree that A came before B. If they don't, you get chaos, corrupted data, a total mess. But if they do, you get a reliable, predictable system you can count on. So to solve this agreement problem, Raft sets up a really simple but incredibly powerful system of roles and rules. Every computer, or node as we call it, has a specific part to play in keeping everything in order. So every single node is always in one of three states. Most of the time, they're just followers, quietly listening and taking orders from the leader. But if a leader suddenly goes quiet, a follower can step up and become a candidate to run for the top job. And if it wins, it becomes the one and only leader, calling all the shots. And to keep things organized, Raft uses something called terms. You can think of a term like a president's term in office or a monarch's reign. Every time a new election kicks off, the term number goes up. And here's the rule: a higher term number always wins. If any node sees a message with a higher term number than its own, it knows it's behind the times and immediately falls in line. It's a peaceful transfer of power built right into the code. So what happens when the leader fails? The server crashes, the network connection drops. What then? Well, this is where Raft's real magic kicks in. An election gets called, and a new leader has to be chosen, democratically. It all starts with a ticking clock. A follower is always listening for a little heartbeat message from the leader. If it doesn't hear one for a certain amount of time, and this part is key, a randomized amount of time, it assumes the leader is gone. It flips into the candidate state, bumps up the term number, votes for itself, and then sends out a request to everyone else. Hey, vote for me. And that random timeout is a stroke of genius because it prevents all the followers from starting an election at the exact same time. But just because you're running for leader doesn't mean you're going to win. The other nodes are pretty smart voters. They don't just hand out their vote to anyone who asks. To get a yes, a candidate has to prove it's worthy. When a follower gets a vote request, it runs through this critical checklist. First, is the candidate's term number legit and not old news? Second, have I already voted for someone else in this term? And third, and this is the absolute key to keeping the system safe, is the candidate's log of information at least as up-to-date as my own. This check is the system's ultimate defense against losing data. It makes sure a new leader can't get elected if it's missing crucial information. Only if it gets a yes on all three does a node cast its vote. And once a candidate gets that yes vote from a majority, more than half of the nodes, that's it. The election's over. It is won. The candidate immediately becomes the new leader and starts its term, ready to run the show. Okay, we have a leader. Now its real job begins, managing the system's official history. This history is kept in what's called a replicated log, which is basically the single source of truth for the entire group of computers. Every single entry in this log is super simple. It just has two parts: the actual command, the thing that needs to be done, and the term number of the leader who created it. That term number acts like a historical stamp, which makes it really easy for nodes to spot any inconsistencies between their copies of the log. So the process for adding new information is this constant four-step dance. First, the leader adds the new command to its own log. Then it sends copies of that entry out to all the followers. The followers add it to their logs and send back a quick "got it" message. And then the leader just waits. It's waiting for a magic number before anything becomes permanent. And here's the crucial part. The leader does not need to hear back from every single follower. It just needs a majority. Once more than half the nodes say, "we've got it," the leader knows the information is safe. This majority rule is what makes the whole system fault-tolerant. It can keep working even if a few of the machines go offline. So as soon as that majority is reached, the leader commits the entry. And this is the point of no return. A committed entry is permanent, it's locked in, and it's guaranteed to survive. The leader then tells all the followers, okay, that last one is official, and they can all apply it. This leads us right to the fundamental promise of this entire algorithm, and the original paper says it perfectly. Once a log entry is committed, it will never change and it won't be discarded. It is there for good. That is the guarantee that makes Raft so incredibly powerful and trustworthy. So we've gone through all the mechanics, the states, the elections, the logs. Now let's zoom out and ask the really big question. Why does this complex dance of rules and messages matter so much in the real world? Well, all these carefully designed rules give us some incredible guarantees. With Raft, they're guaranteed to have one and only one leader for any given term, so there are no conflicting orders. Its strict voting rules mean any new leader is guaranteed to have all the latest data, so nothing gets lost. And because it copies data to a majority of machines, you get a system that can actually survive computers failing. It all adds up to a truly reliable, self-healing, distributed system. So the next time you use a cloud service, a distributed database, or really any online system that just works without failing, take a second to remember Raft. It's that silent, constant election happening behind the scenes, making sure all the computers agree and keeping our digital world consistent, safe, and online.